Nice. Welcome to All Understanding Learning. Today, let us see about the different types of microcontrollers according to the memory architecture. In a microcontrollers, we can observe different types of microcontrollers according to the bit size, according to the architecture we are used, according to the functions we are going to be used. We have seen all types of microcontrollers. Now, today we will see about the very important classification that is two microcontrollers. Maybe the microcontroller may be any series 8051, 8031, 8052 and so on, etc. That is PAC microcontrollers that we have understand classification in detail in the previous video. Now we will see what are the very important two computers of a microcontroller, that is von Neumann is the first and the second one is the Harvard computer. So there is a three parts of a microcontroller. One is called as a CPU, the second one is called as a memory, the third one is called a peripheral and IO devices. So the important one is here what? That is memory. So according to the memory architecture, there is a two types of a microcontrollers. One is called as von Neumann. This is invented by the Princeton University, and Harvard University develop a one more computer later. So these two microcontroller computers are very important to understand clearly. What is the von Neumann computer? What is a Harvard memory computer? Now, see, this is important keynote where we are understanding the two microcontrollers. Now, let us see in detail. So, what is a von Neumann microcontroller? So, von Neumann microcontroller is a simple architecture that consists only one memory. There is a only one memory, that space is occupied by program and data instructions. So the both program code and the data will be operates in the same memory area, so that the data must be accessed sequentially and executed sequentially. So this is the first type of a that is controller microcontroller, von Neumann microcontroller. So see there, first the programming code is fetched by the user and it could be executed. So we understand very clearly by representing these by these two steps. By one is called as a fetched by the programming code F1, and later it is executed, that is represented by the E1 for understanding. So this is the von Neumann architecture. We know that it has a control unit in the ALU, and whatever the input is given, the output is obtained by storing the data, by writing the data. Both programming code and data is represented in one memory only. So that what we understand in the previous, the F1 and E1 both are executed sequentially. First F1 will be fetched, later it will be executed. Now similarly, if the user is gives the second instruction, what happened now? The F2 is fetched, the second instruction is fetched, later it is executed. So there is a individual timing signals for fetching and executing. So it is, if you observe clearly, that is, it is happening serially, nothing but sequentially, one after other. So they see there the third instruction also fetched first and it is executed later. So what is instruction 1, instruction 2, instruction 3? These three are executed sequentially or serially. So let us the second architecture, how it is. What is second architecture we discuss? That is Harvard memory architecture. It has a two memories separately. See there, this is a separate memory space for program fetched by the user, and also the data memory separately. It will stores the data for the execution. Now it is having a separate distinct buses to store the entire the memory what we are going to be used for fetching and execution of a data. See there, what we discuss, there is a separate memory units that allows the parallel fetching and execution of instructions. So there is no need of sequential operation of a F1 and E1, when E1 is executing, the F2, the second next instruction, next consequent instruction is ready for the execution. Already it will be fetched during the execution of the previous instruction. Let us see, let us understand how it is improve the speed of a fetching and execution of a instruction one by one. Let us understand clearly by using the technique called, this is called as a parallel operation, or simply it is called as a pipelining technique that overlaps the fetching and execution. What is the fetching? F1 E1 first instruction, F2 E2 second instruction, F3 E3 third instructions. For these three instruction example, you can easily understand the entire what is called as operation of a Harvard architecture. See there, we have a first instruction is fetched. So what happened now? It will be executed. Before it is executing, what is that? The second instruction is ready to executed by fetching. It will be fetched when the during the E1 is executing. So this is called as parallel operation, or it is called as a pipelining. See there, when the E2 is executing, what happened now? The third instruction is ready to fetch, where it is not happening in the previous Van Neumann architecture, that is serially. First one is fetched, later it is executed. Next it is second one is fetched, later the second instruction is executed, like that. Now see there, you can understand how it is the parallel operation or pipelining. So instruction executed, E2 is executed. During the execution, F3 is ready. Now it is executed the third instruction also. So parallelly, one after other, it is ready to executed. Now this one by means of a two things at a one place. So you can easily understand what is the difference between the von Neumann architecture and the Harvard architecture. What is a sequential operation? What is a parallel or pipelining operation? See there, the fetch one, the instruction one is fetched and it is executed, so that one full instruction is completed. See there, one full instruction is completed now here. Now the second instruction is fetched and it is executed. Now what happened now? It is two instructions are completed its operation. Now the third instruction is same. So three instructions are completed. How you can understand now? Serially, one instruction is fetched and executed. One operation is completed. Now the second operation is completed later. The third operation is also completed later. That is sequentially it is happening serially. So what is this architecture? We discussed in the first type. That is called as a von Neumann architecture. So we can easily understand, my dear students, it is very simple way to understand what is the sequential operation of a von Neumann memory architecture. Now it is not happening like this in the second microcontroller computer, that is latest computer, that is going to be used for many operations because of its advantages of very less time for the execution of a instruction and a number of operations. See there, what is the total time taken for the three instructions in the sequential Van Neumann memory architecture? Total 3 seconds time is taken by the computer. Now what is the time for the execution of a instructions in the next computer called as a Harvard microcontroller computer? See there, the fetch one, the instruction one is fetched ready and it is executed. Before executing, what happened now? The second instruction is ready to fetching. So what happened now? It will be executed. When it is executing E2, it is ready F3. So the F3 is ready to fetching. So it is E3. Now all instructions F1 E1, F2 E2, F3 E3 is ready to fetch. Now you can observe that what is the total time taken for the all three instructions. What is the time taken? Only 2 microseconds. Out of 3 microseconds of a total time period of a fetching three operations, how many microseconds taken? 2 microseconds. Almost 30% of the time is reduced in the Harvard memory architecture, so that Harvard memory computers are very faster as compared to the sequential operating computers called as a von Neumann operating computers. See that, you can easily observe that it is called as a parallel operation or pipelining Harvard architecture. So this is the two computers we discuss according to the memory architecture. I think the students understand a very better way by this. If any comments are there, you please post your comment on your on a comment box. Definitely I can help you by replying your comment. If you not understand, you can freely post your comment so that I can help you better for understanding these memory architectures, maybe von Neumann or Harvard architecture.